Okay, let's move on. The next algorithm that we have to study in this part is SJF. SJF is for shortest job first, and I think its name is telling you all about itself. So for shortest job first, it's very obvious that whichever process has the shortest job, shortest service time, shortest execution time will be executed first. So first of all, let's take a real life example. Suppose that you have to use a printing machine or a photocopying machine in your university or college, wherever. So maybe you go there and there are 5 people in the queue before you, and those people have to print or photocopy a whole book, a large book. And while you have to use the printing machine for just 1 minute to just copy maybe a single page or print a single page. So how inconvenient does that feel, that you have to wait at the sixth number for 5 more people to print a large book while you just have to use that machine for printing a single page. So how about there is a mechanism or that whichever person has to use that machine for 1 second is allowed to use it before the other person who has to use it for maybe 1 hour, right? So this is what SJF is. So in this algorithm, whichever process has the least amount of execution time is given the CPU first, so that that process does not have to wait for the other processes whose execution time is very large. Okay, one more thing. Service time, execution time, burst time, CPU time, these are all the same things, same terminologies. They indicates the same thing, which is actually the time of a process in which it does its work. Okay, one more thing. Service time, execution time, burst time, CPU time, these are all synonyms. They all indicates the same thing, that the time required by any process to do its work. Okay, so for the shortest job first, let's see. Let's take the same example. Let's take this example in the previous slide. We have 4 processes with execution time 5, 3, 1, and 4. Let's take this example for this algorithm too. So this is our timeline, and we had the first process as with the execution time of 5. The second process had what was the so the second process has the execution time of 3. The third process has the time 1, and the fourth process has the time 4. So this is how the original sequence of the processes in the way they came. This is the first process, second, third, and fourth. So for implementing SJF, shortest job first, what will happen in this process, in this algorithm is, first of all, this timeline will be sorted. These processes will be sorted on the basis of execution time. Whichever process will have the least execution time will come first. So in this scenario, you can see the least execution time is taken by the third process. So it will come here. The second least time is second process, right? This will come here. Now the first process is 5. It won't come. The fourth process has execution time of 4. This will come here, and at the end, first process will come. So you can see these processes will be sorted on the basis of their service time or execution time, and then they will be given the CPU. So now this process will have CPU first, the second process will have the CPU after the first process, and then this process, which is actually the fourth one, will have the CPU on 5th number and on CPU on 3rd number, sorry. And the first process is be given the CPU at the very end, at the last number. And the other things for this are the same. So let's see that. Let's calculate. Let's write it here, and let's calculate the waiting time and total time for all these processes again, after sorting, obviously. So the waiting time of this process, okay, one more thing. This is just to make it more clear for you. The first process, this is not the first process, this is actually the third one. Let's write the original numbers of these processes along with them. Okay, the execution, the waiting time of this process now, which is at the start of queue, will obviously be 0. We are talking about waiting time here, and we will talking about total time below. So the waiting time of this process, which was actually the second process, is now, the waiting time of this process here is now 1. You just have to wait for 1 unit now. The waiting time of the third one in this row is 3 plus 1, 4. And the waiting time of the last one, which was actually first before, is 4 plus 3 plus 1. That equals to 4 plus 3, 7, plus 1, 8. Okay, what is the total time? The total time for the first process is 1, obviously, because, why? Because 1 plus 0. Service time plus waiting time is equals to the total time, so that equals 1. Now the total time for second one will be 3 plus 1. Service time plus waiting time, so 3 plus 1 equals to 4. For the next, it will be 4 plus 4 equals to 8, and for the last one, 5 plus 8, that equals 13, 9, 10, 11, 12, 13, yeah, it equals 13.